Thank you, Tim. It's a great pleasure to come and talk to you this afternoon about something that, as I said, it's funded as part of the project as a network, but something that we're still in very early stages, and I'll explain a bit later on as to why it's early stages. So I'm going to talk to you about this area of cognitive computing. That's otherwise known as artificial intelligence, but that has a rather bad name, so we keep it cognitive computing, and how we can use the ability of computers to process information and integrate information to hopefully get some directions of thought in antimicrobial resistance. The diagram at the back here is actually real data. I put that there because maybe on another occasion I hope to come and talk to you about some work that we're doing, that we've been doing for many years now on making a soft X-ray microscope. And this is a diffraction pattern that we've recorded from some bacterial chromosomes. And at the moment, our ability to invert that, get back to the original structure, is a little more limited than I would like, so I haven't put up the structure. But in principle, we have about 50 nanometer resolution, spatial resolution. So I hope sometime to come and talk to you about the use of that in understanding microbes. But let's deal with this. So if you look me up, I'm perhaps not one of the people you would first find in talking about microbial work. I'm a physical chemist, but also a digital chemist. If you look me up online, this is the sort of information you find these days from LinkedIn, Google Scholar, and so on. But of course, I would maintain that I have a real presence as well. Those are these 2D QR codes. Each one of those links back to one of these other pages. So I have some mixed existence between the physical and digital world. And in fact, keeping connections between the physical and digital world is one of the things that we deal with. Some of my colleagues think I've truly gone to the dark side and are much more like that. So cognitive computing is really what a lot of the big companies, Google, Facebook, IBM and others, have been up to for a while. And it's really what it's about extracting connections from data and understanding and drawing inference from that data. We're in the world of big data, but also we're in the world of lots of heterogeneous data. Those pose slightly different challenges. The world of big data is perhaps the slightly easier one. Big heterogeneous data is where we're going to move in the future. And it's that sort of area, the integration of information associated with that, that I think is going to play a very important part in antimicrobial work. And you probably have come across the expressions of deep learning, deep neural networks. It's this attempt to write programs that do what the human mind is very good at doing, of making connections between different bits of data. Learning things is one thing. Unlearning is perhaps one of the most important things that you have to do in these complex areas where the supposition that I might come as a chemist about how something works proves to be completely wrong when I start talking to people in medicine or engineering. So unlearning is just as important as learning and then relearning. And that's, again, hopefully one of the areas that we hope the computational technology can help with. Now, this is a very interesting time to be in. If these happen to come from Wired, but there were other news feeds will have shown you something similar. This is the most recent one. This group of people in the Bay Area have just put up $1 billion for friendly artificial intelligence and have hired the people from Google. Facebook open sourced some of its hardware. Google open sourced its artificial intelligence algorithms. Why did they do that? Well, that's perhaps because there's nothing particularly new in these algorithms. It's very nice that they're open, but actually many of our researchers already knew what those algorithms were. They're probably not hiding anything. If you're a conspiracy theory person, you believe they've got something else under the sheets and they're just trying to convince us all and that their quantum computers don't actually exist yet. But it's open source, which is very convenient, but what does it mean? It really means they think it's all about the data. It's not about the processing of it. It's about the vast amounts of data that they now hold, and that's what is the valuable resource. And I think there's a certain element of truth in that we need to be aware of, and that we need to be collecting large and using the large amounts of data that we have about biological and chemical systems that are involved here. So we do have this issue of big data. There's a lot of it. It's particularly heterogeneous in something where we have to work and span across such broad disciplines. And the data is critical. And in many other areas, when I'm looking after some aspects of the digital economy, we actually consider the revolution that spices had and the spice trade and the change in the nature of the world when the spice trade, when people decided to sail all the way around Africa to get hold of the spices, rather than deal with inflated prices that were coming through the Levant. Radical changes because there's focus now, in this case, on getting the spices, that getting the data and dealing with the data is really important. So in our early stages at the moment, we're dealing about enriching the data such that those collecting data actually mark up the data in a way that it can be understood and used by others, and that's we've got computational processes there. But the data is coming from such broad areas that this is very hard for a single individual to do because it's too broad, and it's actually the breadth of stuff. But we need an intermediary. This is a double spiral staircase. The great thing about the double spiral staircase is that the up and the down don't meet. That's the problem with a lot of the people generating data and using data. We need an intermediary, and the intermediary is frequently now has to be a computational engine, because that's actually the only thing that can work on scale. To do that, we need these semantic technologies to understand things, and here is one of the ones of Semantic Scholar. This is from Paul Allen, the Institute, the other founder of Microsoft. If you try antimicrobial resistance into that, you get some very interesting papers. But the product that we hope to make use of is IBM's Watson. You can imagine what we're going to call the Southampton version. And the particularly interesting thing is it's very good at cooking. Comes up with quite innovative things, and it's actually cooking up a new solution that we actually want. But that's all about the computers helping us. If we're going to do that, we have to help the computers. And the way we do that is we actually have to encode the knowledge that we know in a way that can be processed. That's these ontologies. But our problem is issues of actually getting that into the computer. So I'd like to just finish there by saying, although I'm in favour of the computers doing lots of the work, it's still very important to actually come along and talk to people. And what I want to use the computers for is to suggest who it is who should get together and what they might discuss, not actually to find the answers. Thank you very much. Thank you.